This website has some very useful information for spacing pipes, and I found this particularly interesting and useful. Here they give a diagram, and here's a calculator. Input your data, hit calculate, and it gives you a center line to center line dimension for spacing your pipes. Now I use that calculator to space these pipes, and excuse me, what I found interesting and helpful was that when you use the one flange rule, even though you won't have any flanges in your line, the space between the two lines gives you enough room to do this. It's tight, but there's no clashes. Now, why do you need to do this? This goes back to the same thing I've been stressing through several of these videos in creating a vertical rise or drop on a sloped line. Let's isolate this. This is our 1% slope, and here we flatten out, excuse me, so that this is a true 90 degrees between these two center lines. Because that's the only way that socket knows how to put together two pipes. Now here's what I've seen done, which is incorrect, and if you're doing it, it can't be built. This line is vertical, this line is sloped. And there's the problem. That is not 90 degrees. What people are doing is taking a line and drawing it vertical off to the side. If this is drawn you can see that that line is tilted because this is a 90-degree fitting. Now when we measure that, it's 90 degrees, but it's not truly vertical. So what people do to get around that is draw a vertical line and then move it over and connect it. Now they got a vertical line, but this can't be built this way. This is the proper way to do it. And it's done by put in a 30-degree angle here. And that has no slope on it. It's flat. Then you can put your 90 degree on that. works better if you get in the XY plane. And this line is vertical. If we put a line on that, list it, we see that in the XY plane it's 270 and there is no other angle on it. That's the purpose of this 30-degree angle, is to allow rotation of this fitting to bring this horizontal so that that fitting gives a true vertical pipe. Now if you want to line these center lines up for these rises, here's how you do that. We'll go in here and we'll put this, continue this pipe run. This has to be sloped. And we pick it up again. It's a 30-degree angle. And if we look at that, you can see it's sloped here, but it's flat here. Let's isolate this. If we look at the elevation, we see that this is flat and that this is flat. Put a 90-degree fitting on this. We want to drag this till it's even with the top of that. Take a line up at that end point, turn on our ortho to make sure that's straight and level. Now we need an intersection point out here to move this. And to do that, what I found to be easiest is to draw a line there to there, while copying the center line, and then move it that end point to that end point, but it's not quite long enough, so we'll copy it one more time from there to there. Now if we look at that, you can see we've got a straight line with the center line of that pipe. Simplest and easiest way I know of to get that intersection. We line the apparent intersection. Draw a line from there, and it's going to be perpendicular to this line. Then we'll move the rise and the fitting from from that endpoint to that endpoint. Erase these now. And drag this up and connect it up. Check our continuity. Good. Now you can see those center lines of those rises are exactly in alignment. Let's check the elevation of that rise. And that's the same as the other ones we had back here, 152, 589. There's how to get them lined up. Once again, this is the correct way to put in a vertical rise or drop that's completely 90 degrees from a sloped pipe. Don't forget, Control Save, Control Save, Control S. There is no substitute for it. Do not rely on exiting out of the program and starting it up. As I've said before, program can crash 15 minutes before you decide to do that, exit out and start it up. And how much work do you lose? An hour, hour and a half? You have to do over again. It is a waste of time. Control S. Thank you.